Go.
Hello, good morning to J. Harman bin Buddha. So, let me introduce myself. My name is Fabian Tiong Chong Singh. With me now, Fimbit Lugan, which taking the video, and yang menyediakan slide adalah Awang Mirul and with me also lah. So, our topic today is wind turbine. So as you can see, this is our prototype of our wind turbine. So before that, saya akan terang satu-satu mengenai komponen kami. First of all, di sini kita ada wind turbine, kita ada dua. So with transformer 1 and transformer 2. Lepas itu kita ada power plant dan kita ada electrical grid. Seterusnya adalah distribution grid and consumer. So I will explain each of these components. First of all, I will start with my introductions. So as we know, wind turbine is simply we can say it almost work like a fan, which fan do not produce electricity, while when it work, when it spin, when the rotor spin, fan do not produce electricity, while for wind turbine, when the fan or this rotor spins, it will work or make or produce electricity by moving the rotor, and then it will move the generator inside the wind turbine, where the generator will produce the electricity and will be flow to the transformer. So this blade of this wind turbine is nearly almost 60 meter in real life lah, not for my prototype. So in real life, the length of this blade is like 60 meters. So it's really huge. So this wind turbine, it will turn. The wind will turn this wind turbine propeller, and the blade will move and all turning around rotor, and it will spin and move the rotor, and it will spin the rotor, and the generator will which produce the electricity. So this wind turbine is moving using the method of aerodynamics, which more simply we can say same like aeroplanes and helicopter rotor blades. So wait, let me refer to my slide first. Okay, when this wind turbine move, it will create a pressure, which we have two pressure, and it's almost different, where it will create lift and drag. Where lift, it is more stronger than drag, where it will cause this rotor to spin when the wind blow. So the rotor is we can simply say it connect to the generator, where we can pronounce it as a direct drive turbine, or the shaft and the series of gear, it can be connected to the gearbox. That there are two methods lah, and this speed rotation physically produce or be connected into a small generator if it connects with the gearbox. So these aerodynamic rotations will produce the electricity lah. Okay, next. Okay, there's two types of the wind types of wind turbine, which is the horizontal axis wind turbine and vertical axis wind turbine. So like now that I'm displaying now is the horizontal wind turbine. So if the axis wind turbine, it is just straight up like eagle beater style. So this is the common wind turbine or blade that we using in the countries that are using the wind turbine lah. After that, for the vertical axis, it is more to French inventor. So that's mean this is the vertical axis turbine is morely used in the French lah. Okay, for the next is land-based wind turbine. So for this land-based wind turbine, the range of this size is from 100 kilowatts or can be larger to megawatts. And this larger wind turbine is more effective and it together with the wind plants which provide a bulk power of electrical grid. So after that we have also have offshore wind turbine. So this we can say it in the middle of seas. This offshore wind turbine is really massive or huge, where we can compare it with the Statue of Liberty. So it's really big, and they do not have the same transportation challenge, where for the offshore wind turbine we can bring the equipment by using the ship, not like land. Land we need to use like cars, and the transportation challenge is really big lah. When for example might be jams and traffics, while different for the offshore, where you will not face that of challenge, where there's no traffic in the sea, and you can carry the wind turbine freely without any challenge, because offshore wind turbine is really big. So this is the advantage lah of this offshore wind turbine. So and then we also know that this wind turbine are also powerful, because in the middle of oceans we all know that the wind is very strong. So this wind turbine work when it has a wind. So in the land-based wind turbine, the wind is limited, because there might be houses that block some of the winds, that might be a mountain that block some of the wind. But when you are in the middle of oceans, there's no object that might blocking the winds. So it will produce lots of energy and winds that will make the turbine move, and it will produce lots of electricity energies. Okay. Okay, I will explain more about the equipment, or the equipment that we have will be used when we want to make wind turbine. So first of all, we have a generator. Generator mainly or simply we can set it inside this wind turbine. So when this rotor is spinning, it will move the generator. So inside here there's a generator, where this generator will produce electrical energy by burning the fuel, and the energy will be transformed to the transformer, where this transformer is used to as we can say it's more to alternating currents from a circuit to one circuit or more by increasing, stepping up or stepping down the voltage. So we have two transformer here, and then it will be spread to the power plant. In this power plant, a power plant is industrial facility that generate huge amount of currents of voltage from this from the primary energy. This is our primary energy. So and then most power plant use more than one generator lah to produce the electrical energy. So after that, the power plant will supply the electrical energy to the society that needs the power. So Mainly here we can see it will supply the electrical energy to our electrical grid, where electrical grid is used to deliver these electrical currents to the distribution grid. As we can know, the network or transmissions of this grid is mainly used in this modern world. So this grid is really huge, where it supply huge currents or voltage from this power plant into this distribution grid, where this distribution grid is mainly work to separate the main current or voltage of phase to the consumer. So after the electrical or voltage is separated to the consumer, it will mainly connected to the main meter or electrical meter for each consumer house, where the inside this house there is we can say electrical meter, which it will measure the total power consumed over a time several for each consumer house. So after getting into the electrical meter, lastly it will go to the distribution board, where we can call distribution board is more to a breaker panel, direct electrical panel, DB or DB box, and it that will be the electrical box is equipment that will protect the consumer house from any overcurrent or overvoltage that can be used for the consumer to light up their electronics devices, to charge up their laptop, phones, and to use other electrical equipment. So that's all from me. Thank you.